understand how your brains work, you know that when you learn new things, your brain connects it to things that you already know that are familiar. And so if you can relate something you're learning to something else, it helps you to recall it easier. So I tend to like to explain that this particular chapter relates to linear equations. So if you know your y equals mx plus b stuff and you can adapt with that, you're not really learning anything new, you're just adding to what you already know about linear equations. Yeah, exactly. So, arithmetic sequences are very similar to linear equations. The only difference really is that linear equations are continuous and you can plug in numbers that are decimals and fractions, and you don't with sequences. Linear equations, or like y equals mx plus b. Okay? But we're not going to use y and m and x and b. I'm just trying to help you connect it in your brain that it's the same type of process. Okay, first of all, let's look at the different types of formulas for these. Oh, and I should have defined arithmetic sequences first, probably. So let's throw a definition in here. The definition of arithmetic sequence is that the sequence is created by adding the same number to each term to get the next number. So like the one we were just looking at, we looked at a recursive formula a few minutes ago where it added 3 each time. That was an arithmetic sequence because each number was 3 more than the one before. Okay? So recursive formulas are done by finding your number by taking the previous number and adding what we call a common difference d. Okay, so d is what we call the common difference. Okay, so like if we look at one of the problems we were just doing, I can find that page. This one here, number 35 on the previous assignment. We were practicing a recursive formula, and each one took a previous number and added 3 to it. So what is the number 3? 3 is d. It's the common difference, because if you look at each of these numbers and you subtract any of them from each other, so like say 8 minus 5, what do you get? 11 minus 8? 14 minus 11? Oh, so a difference is when you subtract, and a common difference is getting the same number every time you subtract. That's why this is called the common difference. Okay? Now this formula, the only thing that's different between the way this formula and that formula is written is that they've put the 3 first and then added the number. So does that really matter at all? No. Okay. Alright, then the more important one to know is the general formula. You really need to just know both of them, but this is the one that's more useful. The general formula to find a sub n is found by taking the common difference times n plus a number c, and c is referred to as the compensating term. And what the compensating term does is it helps you to start the sequence in the right place. To start the sequence at the correct number. Okay? So, let's relate this formula that I just gave you to the linear formula y equals mx plus b. What do you notice that they have in common? instead of x, the domain, the number we plug in, we have the letter n, the number we plug in. X was all real numbers with linears. With sequences, n is just the natural numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So instead of the graph being a continuous line, the graph would be a line of dots that are all lined up, collinear dots. Okay? Instead of having slope m, we have common difference d. If you're adding the same number each time, doesn't that act the same as a slope? Yeah. So you're adding the same number over and over and over. That's just like a slope. Something's increasing consistently by that slope, that rise over run, correct? Instead of having starting point y-intercept b, we have a starting point c. This is not the first term of the sequence, but rather just a number to get us to the first term of the sequence. And then a is our range. It's the number we get out. It's the actual numbers in the sequence, and we use a sub n instead of y. And the sub n just tells us which number in the sequence we're dealing with. Do you see how they totally relate? Okay, good. Okay, let's do some examples. Oh, by the way, the general formula, just to review something that I did do in the notes on your video, general formula is sometimes also called find the nth term. There's times when they actually won't say find the general formula. Instead, they'll say find the nth term. So that's saying find a formula, because instead of actually having a number for n, you have an n for n. So it's a formula. So that means the same exact thing when you see that on a problem. Okay, let's do an example. Okay, find the nth term of a sequence I have different ways that these are listed. Let's do this one. 2, 6, 10, 14, 18, etc. Then that's the first part of the problem, and then we're going to find the 41st term, just for the heck of it, because I have that written down. Okay, I guess I should move this entire thing up so we can see better what we're doing. Okay, find the nth term of this particular sequence. So in other words, what are we finding? I didn't ask for exactly what it's called. I said it a different way. We're finding a general formula. And then after we find the general formula, it's easy to plug in 41 and get an answer. Okay, the first thing we need is D, our common difference. So step 1, find D. So you look at your numbers and you subtract them if you need to or whatever, and you notice that it's adding 4 each time. Is it possible that it could be created by adding a negative number each time or subtracting a number each time instead of adding? Does that mean the same thing, just a negative slope instead of positive? Yeah, it still fits in the same category. Okay, but this one's a positive 4. So then to find our formula, we are going to plug in an n value and a value to find C. You can kind of sort of sometimes do this in your head, but I'm just going to show you how to do it with a point. So we have a list of our sequence. This is a sub 1, a sub 2, a sub 3, a sub 4, a sub 5. And so that means n equals 1 when a equals 2. N equals 2 when a equals 6. N equals 3 when a equals 10. So pick one of those sets of numbers, and let's use our little formula we just learned. A sub n equals dn plus c. And let's plug our 4 in here, and plug one of our sequence terms in here. So how about if we just use the first term? So the first term, n equals 1, is a sub 1 equals the first term of the sequence 2. So what am I actually plugging into this formula so that I can find C? I'm plugging in the number 2 because that's the first number of the sequence that I would need to get when I add 4 each time and I want the first number. So what number C do I have to add to 4 to end up with 2 as the first number? A negative 2. Good. So our compensating term, our starting point to get us starting the right place, is negative 2. Notice how negative 2 is not the first number, it's a number to help us get to the first number. So the final answer for the nth term is a sub n equals 4n minus 2. There's the first part of the problem. Done with that. Then it says use our formula to find the 41st term. What does that mean we do? So we're finding the 41st term, so we call that a sub 41. We plug in 41 for n, subtract 2. So 4 times 41 is 84, no, bigger than that. 164 minus 2, so 162. Does that sound right? Okay.